Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Welcome back to my channel. Today we're going to be continuing the series on power rule, and we're going to be working on episode 3 of power rule. So the first episode that I worked on for this series talked about the introduction to power rule, and in that particular video I went into detail and talked a lot about power rule and talked about the sum and difference rule, plus like a mini rule or a mini occurrence that happens whenever a constant is multiplied by a function and how to differentiate such function. So I basically went into detail in episode 1, and episode 2 is just another question. I went into detail as well, and in this video I'm going to be going into detail as well, but not as detailed as episode 1. So I advise, if you haven't watched episode 1 and you want to have a good grasp of this information in calculus, I would advise you watch episode 1 of the series. But if you know you're comfortable, you're confident, just watch. You can just continue with this video right now, or you can start from episode 2. So thank you guys and welcome back. So now I would first of all explain something before we actually solve the problem, that we have today. So you can see in this page I pre-wrote the power rule, the sum difference rule, and the constant multiplied by function occurrence. So the power rule is basically whenever you're given a function, right, with the variable x. In this particular case, we're differentiating the function with respect to x, but this looks like a term that it has a power where here n is a non-zero real number. So n is not equals to 0 and n is not equals to an imaginary number. You may be wondering, what do you mean by an imaginary number? These are numbers where they can be represented in the form of I and j, or numbers whenever you get them. You get imaginary numbers whenever you have a square root of a negative number. So if you have square root of, say, square root of a negative 4, or square root of -1 or -1 million, those ones are imaginary numbers because they're not real numbers. So anytime you have a square root or any form of root, a cubed root, or fourth root, or fifth root, and any of those roots have negative inside of them, those aren't real numbers. Those are known as imaginary numbers. So n is not 0 and n is not an imaginary number. So for us to be able to apply the power rule, we have to make sure that n, the power here, is non-zero. So that means n is not equal to 0 and n is a real number. Therefore, it cannot be an imaginary number. So I gave you a quick example here. If you have x cubed equals 3x squared, we see here that the power here of this particular question here, 3 drops down. So here you end up x cubed. This 3 drops down here and becomes the coefficient of x. And then the power will be decreased by 1. So you end up with 3, because the 3 comes down, then you have x. And then the power has to be decreased by 1. So 3 minus 1 is 2. So hence that's why we have 3x squared here. And then you have the sum and the difference rule, where basically if you're given something to differentiate and it is a polynomial function, right? So say like 5x cubed minus 9x squared plus 11x minus 25. Right, what you're trying to explain right here, or what the rule is trying to say, is that you should differentiate you can differentiate each one of the functions. So even though the entire function is 5x cubed plus 9x squared plus 11x minus 25, each one of this function is a subfunction. So you can do the differentiation of each one of the subfunctions. So in this case, say the subfunction is f of a, right? And in this one, the subfunction is f of x, and here this is g of x, and this one is h of x, and this one is I of x. So basically what do? You're going to differentiate each one of these terms with respect to x and then add all the differentiated values together. And that's what the sum and difference rule is saying. It's the same thing as And one thing you have to know is when you see the plus or minus, it's not trying to do what we usually do when we're doing quadratic formula or solving quadratic equations. When you see a plus or minus sign in the sum difference, it's trying to tell you that f of x plus g of x, or the question could have a negative in between two subfunctions or a positive in between two functions, not both. It could be any of the two, not necessarily that we're going to have f of x plus or minus g of x all the time. No, it could be f of x plus g of x, or the question could be f of x minus g of x. So in this case now we have, in this case here, the black pen, we have a negative sign in between the two terms. Here we have a positive sign in between these two terms, and here we have a negative sign in between these two terms. That's what we're trying to say. So that's what we do. And then the last one is whenever you have a constant multiplied by a function and we're expected to differentiate that entire information, what you're supposed to do is bring out the constant and then differentiate the function, and whatever you get is you just multiply both answers together. So here the constant multiplied by a function is just the same thing as saying bring out the constant, bring that out, then you do a dot here. That dot is supposed to signify multiplication in calculus, and then you differentiate the function, and then whatever the answer for the differentiated function is, you multiply it by the constant, and then you get the answer. So that's basically what we're doing here. I hope you understand what I'm doing. So we discussed the power rule, how the process of the power rule works. We did the sum and difference rule, and then we did the constant multiplied by the function occurrence. I don't know if it's a rule. I just put occurrence just because it happens, and I think with time you're going to realize it happens frequently. I don't think occurrence is double R. I think it's just one R. So I'm just going to rewrite that. But yes, so this is how it is we work with it. Hopefully I'm not too fast, and then when I'm doing the problem now, inshallah, it will be easier for you. Inshallah, it will be easier for you guys and for me as well to understand. So the question we have for this episode is 4t cubed. So we have 4t cubed minus 6t squared plus 8t minus pi, and this is the entire function, so the function will be y of t. Remember the reason why we're doing y of t here is because t is the main variable, so t is equals to variable. If the variable here was m, we're going to have the function y of m. If the variable here was x, we're going to have the function y of x. If the function here is, if the variable here is p, like the episode 2, we're going to have y of p, or yes, that's it, y of p. The variable here is represented as L, we're going to have y of L. So that's what's going on here. So now the first thing we have to do now, since we're differentiating, is to do this. So we have d of dt, so we're differentiating the function with respect to t, since t is the variable. So y of t equals 4t cubed minus 6t squared plus 8t minus pi. And this is our question. So now we start. We're going to start with, remember the first thing we're going to apply here. Now that we've written that, we have to now separate, like basically do the left side of the equation, the left side of the equation and the right side of the equation. So d of dt of y of t equals this right here. Same thing, d of dt of 4t cubed minus 6t squared plus 8t minus pi. So now you see, remember what I showed you right here? See what we're given? We have this. So definitely, because we're dealing with sum and difference rule, we can break down a function into sub-functions in order for us to be able to solve it, especially for students that struggle. So here we have d of dt, y of t. So we have d of dt 4t cubed minus d of dt, okay, of 6t squared, okay, plus d of dt of 8t and minus, oh no, that's too much of shading, minus d of dt of pi. So what does that mean, d of dt of pi? So this is what we end up with. So we have 4t cubed minus 60 squared plus 8t minus pi. And one thing you should know is basically this. You end up with this question. What do you think you should do? Remember, we're trying to differentiate each one. Now, if you go to the previous page, you'll see what I explained here. Now that we've separated it, we can now focus on each one of the power rule and see what do we have. We have a variable with a power, and the power is non-zero, and the power cannot also be an imaginary number. What do we have in this case? We have the same thing. We have this. We can apply the power to all of them because each one of them have power. The variables have a power that is non-zero. 3 is a non-zero number and it's a real number. 2 is a non-zero number and it's a real number. The power of the variable t by itself is 1 because it's not t squared, t cubed to the fourth, or t to the half. So we know that anytime we have a variable sitting by itself without any visible power or with an invisible power, we immediately know that that power is 1. And we know that 1 is a non-zero real number as well. So now we can apply the power rule. So the first thing we do is, so this is the first thing we do. We have d of dt, y of t. So you have 4, which is the remember what I told you guys about? You can, when you do the constant multiplied by the function occurrence, you bring out 4. You have d of dt, so that's 4 multiplied by d of dt of t cubed. Okay, remember? Constant multiplied by function, and you bring out the constant and you do the differentiation of the function, minus, bring out the constant, so you have c, and then you have d of dt of the function by itself, so you have t squared, and then you have plus, you bring out the constant, we have 8, so we have d of dt of t. And now, if you've been doing calculus, or basically even the basics of calculus, will tell you that anytime you see what they call it, you see a constant, you're going to differentiate, and you differentiate a constant, you're always going to get 0. And what is pi? Pi is equivalent to 3.142 or 3.14159. Simply, what are we doing here? We have to call it 0 because it's a constant, right? It's the same thing as differentiating 2 or a billion or 1.4 or 5/7. They're all constant. Pi is also a constant. It's a decimal. So therefore, it's going to be 0. So minus 0. So you have d of dt, y of t. So you end up with 4. So what is the differentiation of 3t squared? So here we just do a dot, and the dot, what did I say? It signifies multiplication. So dot. So power rule here, we're going to bring down the power, so we end up with 3 and then t, and then we're going to decrease the power by 1. So 3 minus 1, that's 2. So 3t squared minus 6. We're going to bring down the power to be the coefficient. When we bring down the power coefficient, we have to decrease the power of the variable by 1. So we end up here with c. So 2 minus 1 is 1. So then you have this next one. 3 times 2, because 2 has to come down. That was my bad. Differentiation of t squared is 2t. So you end up with 2t. And then you have plus, right? Plus. My plus looks really weird. So plus, like if we get a. So plus 8 Now, what is the differentiation of t? The invisible, since t stands alone, that means it has an invisible power, which that invisible power is actually 1. We bring down 1 to mean the coefficient of t becomes 1t, and we decrease that power by 1. So 1 minus 1 is 0. So t of 0 is what we end up having here. And then we have minus 0. We don't have to write that down. So on the next, let's go to the next page and rewrite this, and we work on it. So we have from the previous page, 4 multiplied by 3t squared minus 6 2t plus 8. So 8t to the 0, remember t to the 0, any variable to the 0, any constant to the 0 is always going to give you 1. So t to the 0 is just 1, so 8 times 1. So here we have d of dt of y of t, and here our answer would be 4 times 3 is 12, so we have 12t squared minus 12t plus 8. So this is our answer. So this is the answer to what we just solved, and I hope this is going to be very helpful to everybody that is watching this video. I know that my solutions are always in detail, and some people might be impatient, but the whole purpose is for you guys to learn something enough that you become so confident that you would not be dependent upon a tutor in order for you to succeed, which is my goal for this channel. I like to go into detail. I like to be able to explain something as though you're beside me and I'm teaching you step by step, so you can have a good way of thinking about questions. So if you guys have any questions for me, please go to the comment section. You should also try problems in your textbook and assignments, that whenever you're studying Power Rule, and I think that would be really helpful for you guys. I also think that you can go online, and if you do some problems that are not related to the problems I'm doing on my videos, you should use any good differentiation app, or you should use your calculators to help you guys. So I'm currently using Symbol Lab. I use Symbol Lab online. You guys can go check it out and do the derivative. Just play around with the derivative calculator online in Symbol Lab. I'm not saying you should get the paid version, and this is not sponsored in any way, shape, or form. Just something that I use whenever I'm doing my own personal study. So when you use when you use that resource, you're gonna be able to kind of navigate and just play with it a little bit with answers you already know to be right. And then when you're sure you're inputting the values right, then you can be sure that you can trust your way of inputting and trust the answer. So when you do it, you can be able to know that when you're doing your own practicing, you're not super dependent on a tutor, because you know how things work, and you become a student that is consistent and striving in and out of class and in and out of tutoring sessions or videos. May Allah subhanahu wa ta'ala make it easy for you guys. Amin ya Rabb. And may Allah strengthen you and strengthen me as well. And hopefully you guys are learning a lot from my videos. Please watch my videos. I've done videos on product rule, chain rule, quotient rule is coming up soon, inshallah. And just keep striving. I wish you guys all the best. Please please don't forget to subscribe. Don't forget to go down in the comment section and tell me what you guys want to see. And don't forget to give this video a thumbs up, and also suggest what you'd like to see. And please click on the notification bell so that you're consistently alerted on previous videos and on future videos. You guys take care of yourself. Assalamu alaikum wa rahmatullahi wa barakatuh.